All right, question number 3, we have 5 parts. So it says, suppose a random sample of size 75 is obtained from a population whose size is n equals 20,000, and the population proportion with a characteristic is p.4. We're going to complete parts A through C. So we're going to describe the sampling distribution of p hat. So we need to check to see if it's approximately normal. So I'm going to just compute both of these numbers with the calculator. So first we got to make sure that 75 is less than 5% of the 20,000. So we're going to do 0.05 times the 20,000, and 1,000 will be the number, and we're certainly under that. We are less than 5% of the population. The second criteria is we're going to multiply n times p times 1 minus p. So n is 75, p is 40, so 1 minus 40 will give us 60. So the 0.4 times 0.6. This number we need to be greater than 10. Okay, and it's 18. So both of these criteria check out, so we can say that this is approximately normal because we are less than 5% of our sample size, and we are greater than 10. All right, we're going to determine the sample mean. The sample mean is going to be equal to the population proportion, so that's going to be 0.4. The standard deviation, we're actually going to have to compute that, so remember this is our formula. I'm just going to recall in our calculator we're going to do second square root. I'm going to make a fraction, alpha y equal enter. Now if you don't make the fraction part, you just got to make sure you put the top in parentheses in the bottom so that it gets it all. So if I just make the square root, and I'm going to open up parentheses for the top, and then I'm going to do 0.4 times 0.6, close it, and then divide it by, so that square root is still extended, means we're still under the square root, which is what we want. And then the sample size n on the bottom is 75. And so now I can arrow out. So as long as all of that's under the square root, the top is separated from the bottom, it will compute it correctly. So 6 decimal places, 0, 5, 6, 5, and it's going to be 6, 8, but it's going to go up to 9. 0, 5, 6, 5, 6, 9. 0, 5, 6, 5, 6, 9. That's going to be our standard deviation. All right, so now we're going to find the probability of obtaining 33 or more individuals with the characteristic. That is greater than 0.44. So how they got this 0.44? Remember, p hat is going to be equal to x divided by n. So if x is 33 divided by n, which is our sample size 75, this is how they're getting that 0.44. Some problems may not equate that for you. So applying this to the z-value, we are looking at this probability that the p hat is greater than 0.44. Converting that to a z-value, probability p hat minus p divided by the standard deviation, which is p times 1 minus p over n, greater than or equal to. Now over here we're going to apply the number, so we got 0.44 minus the proportion, which was 0.4, divided by the standard deviation, which is going to be, which we got it to 6 decimal places, but I'm just putting the numbers in. 0.4 times 0.6 divided by 75. Now, at this point, we can get a z-value, find it on the chart. However, I'm going to just go from here and do it with StatCrunch and just plug in these numbers. So, get more help, StatCrunch, and it'll be the same as normal. We're going to do stat calculators, normal distribution, greater than, the mean is 0.4 of the proportion, The standard deviation, I can just type in this 6 decimals. I can type in the square root. This whole expression, I'm going to go ahead and do the rounded number. So 0.056569, round it to 6 decimal places, and we want to be greater than 0.44. This is giving us a probability of 2398 when rounded, 2398. And then we're going to do the same thing. What is the probability of obtaining 24 or fewer? So that is 0.32. So I'm going to do the same thing, but we want less than, and we want 0.32. Everything else is going to be the same, not the mean, this number down here, 0.32. So 32 or fewer for my proportion is going to give me 0.78687 around it, 0.787.